So inside of the e function is x cubed. So that's what I'm going to let u equal to. I'm going to take the derivative, so I get 3x squared dx. And I'm going to take this, and I'm just going to rewrite it, e to the x cubed x squared dx. All right, so I can see I can put the u in right here, so that gives me e to the u. And I'm looking at x squared dx. So this line right here can be rewritten as 1/3 du is x squared dx. So 1/3 du. Okay, I know how to do that. So that's e to the u. So that gives me 1/3 e to the u, right? Because you know that's what the antiderivative of e to the u is. And I put the x's back in. And there it is. Okay, so let's do number 10 here. So number 10, inside of the exponential function 5 is e to the x. Okay, so I'm going to let, for this one here, I'm going to let u equal e to the x. And you know the derivative of e to the x is e to the x. Okay, so I'm just going to rewrite this. I'm going to put the 5e to the x first times e to the x dx. So by doing that, I'm hoping you can see this is this. So this gets a du. And then I've got 5 to the u. I know what the integral of 5 to the u is. It's 5 to the u over ln of 5 plus c. And then I just put the u, or the x's back in for the u's. And that gives me 5 to the e to the x over ln of 5 plus c. Okay, so here's some more with e's. So again, I'm always letting u equal the inside function. So I know the derivative of e to the 2x is e to the 2x times 2, right? Okay, so if I take this guy, just rewrite it, 4 plus e to the 2x, and then I would move that e to the 2x dx off to the side. So I know that this goes in here, so this is root u. Now I'm thinking, e to the 2x dx, e to the 2x dx. So if I take this and multiply both sides by 1/2, I can take out e to the 2x dx and put in 1/2 du. So 1/2, and I'm just going to rewrite this u to the 1/2, and then I take the antiderivative, so u to the 3/2 times 2/3 plus a c, so 1/3 4 plus e to the 2x, all to the 3/2 power plus c. All right, let's try this number 12. So they're getting trickier, right? So number 12 here, I'm going to let u equal, letting u equal the denominator, not so good. How about u equal the inside of the e function? So then the du is, erase that, 1/2, right? You gotta remember your derivative rules. 1/2 x to the negative 1/2 dx. So I'm just going to rewrite that negative exponent, put it in the denominator. All right, so let's go and rewrite. Remember, so many times if you rewrite it, it makes so much more sense. Okay, let's do it. So I'm going to take, and I'm just spreading it apart, right? Taking this, and I'm just going to say e to the root x times 1 over root x dx. All right, let's see what I've got. So this is my u, so this turns into e to the u. And let's think about what I've got here. I have 1 over root x dx. 1 over root x dx. I just have to multiply by a 2 over root x dx. So 1 over root x dx comes out, 2 du goes in. You know you could pull the 2 outside and take the antiderivative. That's e to the u plus c, and you put the x's back in. So 2 to the root x plus c. All right, last one here. I'll stop for a minute. Okay, so this here, the inside function, will be 1 over x. That's what's inside the e function, right? So be careful. That's like saying x to the negative 1. So many times, since we're doing derivatives and integrals at the same time, and you're going to be doing this for the rest of class, it's just going to be. So you have to remind yourself that the integral of 1 over x dx, that's ln of x. The derivative of 1 over x is not ln. Derivative is negative x to the negative 2. So let's rewrite that and see what that is. That's negative 1 over x squared dx. Okay, so if I take the time to rewrite this, e to the 1 over x times 1 over x squared dx. Let's see what I've got. I can take this and write this as e to the u. And then this one, 1 over x squared dx. Well, I've got it right there except for a negative sign. So negative du is 1 over x squared dx. So I can replace this with a negative du. So be careful. You want to put parentheses there because it's multiplied. So then you can say, I can pull that negative outside, and there it is. So the antiderivative of e to the u is e to the u, and you put the u's back in. 1 over x plus a c